So we will be discussing the questions from year 2024, October-November session. The question from probability and statistics 1, which is the paper 5. So paper 5 too. Okay, so let's have a look for the first question. Okay, so in the first question, we are given a table here. They are talking about the students choose exactly one, okay, of tennis, hockey, or netball to play. So the student can choose only one sport here. So the table shows the number of students in year 1 and year 2 at the college playing each of the sports. Okay, so one student is chosen at random from the 120 students. So you know that by right you should have 120 students in total. Event X and N are defined as follow. So they give us a definition for the X and also the event N. So X means the student in year 1, N means the student plays netball. Alright, so let's have a look what they want us to find. So find the probability of X given that N happen. So this is a conditional probability. Alright, so just to recall back, what is the general formula for conditional probability? So if let's say you're having A slash B, that means B happen first, right? Followed by A. So the general formula will be A intersect B divided by the probability of B. So this is the general formula for conditional probability. Okay. And now let's have a look for this one, X given N. So our general formula will be the probability of X intersect with N divided by the probability of N. Okay, so what do we have for X intersect with N? So we are looking for this one where X is the student in year 1, right? So X is the student in year 1 and then intersect with playing the netball. So year 1 and playing netball is 12 person. So you're having 12 over 120. Or you can just put it as 12 also can, because later, right, the total is the same. 120 and we need to simplify that. Right, so now let's have a look for the netball. So the probability of N means the total number of students or the probability of students who playing the netball. So the total number of playing the netball is you have to take 12 plus 28. So these two numbers, this group of number are the students who play the netball, right? So when you add them together, you'll be having 40. So it should be 40 over 120. So simplify this answer. By right, you'll be having 3 over 10. Or of course, you can write it out as 0.3 lah, as your final answer. Okay, alright, so this is what you have for part 1A, part A, sorry. Okay, then after that we are looking at part B, still a conditional probability, but they are saying that N slash X, given that X. So the general formula is still the same, N intersect with the X divided by the probability of X. Okay, so now I need to know what is the intersection path for X and N. It is the same. Year 1 with netball, it is still 12 over 120. Then divided by the probability of X happen. So the X means the students in year 1. So what is the probability for the students in year 1? So what you need to do is you have to add all the number here together. 16 plus 22 plus 12. Okay, by right, you'll be having 50. So it should be 50 over 120 for the probability, the total probability, the total number of students, right? So after you simplify them, by right, you have 6 over 25 or 0.24 as the final answer. Okay, so to answer this question, basically you need to remember the formula, the general formula for a conditional probability. All right. Okay, then next one, for part number C, they want us to determine whether or not the X and N are independent events. Okay, so highlight the keyword independent. Okay, so to prove whether the result is independent or not, you need to remember the criteria or maybe the how to say, the rules lah. All right, so if let's say the event are independent, then generally you are having X intersect with N should be equals to X multiply with the event N. If let's say independent lah. Okay, all right, so now we need to find out. Okay, so X intersect with the N. So just now we already get the probability, which is 12 over 120, and you should get 1 over 10. Okay, then after that, I want to calculate the probability for x multiply with the n. We also calculate it just now as the denominator. So the probability of n is 40 over 120. So you can put 40 over 120. The probability for x is 50 over 120. So you multiply them together. Then you see what's the value that you get. So you get 5 over 36 for this case. Then you try to compare these two values. So when you want to compare these two values, you realize that these two values are not the same, right? X intersect with n, it is not equals to the probability of x multiplied with the probability of n. Therefore, x and n are not independent. If they are independent, then the value should be the same, right? So our conclusion is they are not independent. So in this solution here, I think you need to really show clearly the value of these two probability, and you need to compare them before you can make any conclusion. All right. So this is how we get the part C. Then let's have a look for part number D. Okay, so for part number D, one of the students who play netball take 8 shots at goal. Then on each shot, the probability that she will succeed is 0.15, independently of INA are the shots. So find the probability that she succeeds fewer than 3 of these shots. Okay, so generally if you have a look for this question, right, the structure of the question is you are having 8 shots in total, and then less than 3 shots, something happen. Okay, so the something happen here means succeed. When you're having this kind of structure of the question, right, so basically it is binomial distributed. So you can write it out as the y is the number of shot which succeed. So, or the number of succeed shot. So y is binomial distributed. The total number of shot is 8. The success rate for one shot is 0.15. So where 8 is your n, okay, then your 0.15 is the p. When you're having a binomial distribution, if they want you to calculate the probability of x equals to a certain number, x equals to r, the general formula is NCR, p power r, q power m minus r. Where you need to know that the q here is actually 1 minus p. Okay, so this is a general formula when you want to calculate the probability for a binomial distribution. Okay, so they're asking for y smaller equals to 3, fewer than 3. So highlight the keyword fewer. Fewer means that not include the 3, it should be smaller than 3. But there's no equal sign here. Okay, so when there's no equal sign here, that means you have to calculate the probability for y equals to 0, which is 8c0, 0.15 power 0. The q is 1 minus p, right? So you should have 0.85. So 0.85 power 8. This is y equals to 0. Then you also need to include the calculation for y equals to 1. And also y equals to 2. Okay, and then I think you should stop here. You shouldn't include y equals to 3 because in our symbol here, right, or in the question, they said fewer than 3. Fewer means it doesn't include the 3. Therefore, in your calculation for the probability, it shouldn't include the 3. So we'll stop here. Try to press the calculator a little bit and try to get the final answer. So for me, the original long answer that I get is this one. And of course, we cannot keep the answer so long. We can simplify it, become 3 significant figure. Alright, so this is what we have for question number 1. Alright, so now we are at question number 2. They want us to find the number of different arrangement. Highlight the keyword arrangement. There are 9 letters here in the word algebraic. Okay, so usually before I start, right, I will want to analyze how many letters do I have first. So from here, I actually have 2A, 1L, 1G, 1E, 1B, 1R, 1I, 1C, right? Okay, so I want to know there are how many repeated letters and everything. So from here, I can see that I'm having 2 repeated letter A, or maybe the 2 identical A. Right, so when they're talking about the keyword arrangement, So in the solution here, basically it will be about permutation. Arrangement means permutation. So your step will generally having something like factorial or maybe NPR. Okay. So we are having 9 letters here. So to arrange 9 letters, I will need to have 9 factorial. But from these 9 letters here, there are 2 identical letter A, right? So you have to divide it by 2 factorial. So this is something like for 2A because of the 2A. Therefore, when you simplify this expression, your answer should be 81440. So this is what we have for part A. And let's continue for part number B. They want us to find the number of different arrangement of the 9 letters in the word again, okay, in which there are no more than 2 letters between the 2 A's. So no more than 2 letters. No more than 2 letters means can be 0 letter, can be 1 letter, can be 2 letters. But it cannot be more than 2 letters. That means cannot be 3, 4, 5 letters between the 2 A's. Okay, so if you have a look for our letters again, we are having 2A and all the rest of the letters are different letters. They are not identical anymore. So what should we do here is, we can try to consider them into different cases, because no more than 2 letters means that first case is you can assume that the A has no letter between them and you bundle them together as one object or one unit. Okay, so these 2 letters as one unit, then you are still having 1, 2, 3, 4, 5, 6, 7. Because total you're having 9 letters, right? So you still have 7 letters here, and these 2 letters you treat them as one unit here. So now you want to arrange the 8 unit here. 1, 2, 3, 4, 5, 6, 7, 8. So when you want to arrange 8 letters and they are all different letters, so the arrangement will be 8 factorial. So this is the first case that we have. So 8 factorial here. And after that, we want to consider the case where I'm having 1 letter between the 2A. So to ensure that there's 1 letter between the 2A, right, I will treat these 3 letters as 1 unit. Okay, so remaining I still have 6 unit outside, 6 letters outside. Okay, so total you're having 9 letters, but the A/A, okay, A space A basically is 1 unit, yeah, because I want to make sure that there's only 1 letter between these 2 A. Okay, so let us try to consider how many place can I arrange, maybe I would say how many place can I place the A space A, I mean this unit. So you can have A space A here. You can also have it at the second, as the second letter. Okay, you can also have it at the third space or third letter. Okay, so you can also have it as the fourth letter. Okay, and so on. So if you try to count, basically the A space A, right, will have 6 different places to be arranged. So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, sorry, it's 7. 7. So you have 7 space to place the A space A. So I'm having the 7 first. Okay, so when you place this particular unit, right, and now we need to consider the number of arrangement for the letters in the other space. So that means I need to consider the letter here, 1, 2, 3, 4, 5, 6, 7. To arrange the 7 letters here, and all of them are different letters, therefore you have to multiply with 7 factorial. Arrange 7 letters into 7 space, right? It should be n, should be 7p7, or you can write as 7 factorial. Alright, so again, the 7 here without the factorial one means that you are placing this whole unit into the available spaces. So there are 7 in total. Then the 7 factorial is to place the 7 letters, the other 7 letters into the 7 space, which is 7p7. And usually we can simplify by using 7 factorial. Okay, so this is the second case that we have. Then after that, how about the third case? So just now has no letter between the 2a. Then you have now one letter between the 2a. So we try to consider 2 letters between the 2a. Okay, if you have 2 letters between the 2a, I treat this whole thing, the 4 letters here as one group. So instead have 5 letters outside. Okay, so the process is the same like what we try out for this example. Okay, so for this one, you need to place the 4 letter here first as one unit. So this is the first place you can put. You can put your A slash just A at second place, then the third place, fourth, fifth, and sixth. So you're having 6 different space for this one. And after that, you need to consider the arrangement for the 7 letters in the 7 space here. So again, the same thing. To arrange 7 letters into the 7 places or 7 space, it is 7p7. So 7p7 means that it is actually 7 factorial. You can try to have a look and see basically 7p7 and 7 factorial should be the same value. Alright, so the question requested for no more than 2 letters. So that means you have 0 letter, 1 letter, and 2 letters. That's it. So it cannot continue with the 3 letter, 4th, and so on. Okay, so these are the 3 possible cases for the arrangement. Therefore, to calculate the total arrangement, it should be 8 factorial plus 7 multiplied with 7 factorial plus 6 multiplied with 7 factorial. So by right, you should be getting this one. 105840. Yeah, so this is how we solve question number 2. Okay, so we are now at question number 3. There's a fair coin and also an ordinary fair, 6-sided dice. Okay, so they are coin and dice, and all of them are fair, right? So are thrown at the same time. The random variable x is defined as follows. So we are having a random variable x. If the coin shows a tail, then x is twice the score on the dice. Twice the score. If it is a head, then x is the score on the dice. Okay, then if the score is even, we should say like this, x is the score on the dice if the score is even, and x is 0 otherwise. That means if even, then it is the score on the dice. If it is odd number, then it should be equals to 0. So draw a probability distribution table for x. Okay, so for this question, there are more than one method to solve it. You can use either the possibility space diagram or you can use a tree diagram to help you. Okay, so as an example, maybe I show you the possibility space diagram first, because you are having dice and also coin, right? Okay, so I can draw a table with all the possible outcome where I'm having dice and I'm having coin. So for the dice, I'm having 6 numbers here. 1, 2, 3, 4, 5, 6. Okay, then for the coin, I'm having tail and also head. Okay, so since the probability, the coin and also the dice are fair, right? So if they are fair means that to get the probability of tail, it should be 1/2, head should be 1/2. So to get the probability for all the number here should be 1/6 because it is a fair dice. Alright, so you should know about this first. Okay, then after that, we try to list out the possible result. Okay, so like what the question mentioned, if it is a tail, then x is twice the score. So at the tail part, when you throw the dice, which is equals to 1, the score of x should be equals to 2. So 2 should be equals to 4 because they say twice the score for all the coin that's showing the tail, right? So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, 6 times 2 is 12. Okay, then if let's say the coin shows the head, X is the score on the dice if the score is even. So if let's say I got the head for the coin, then when the even score, it is equals to the particular score when it is even. So if let's say I throw a dice, it is a 2. So you should get a 2 here. Okay, if you throw a 4, you get a 4 here. If you get a 6, throw a 6 and the score is a 6. Then X is 0 otherwise, means that if let's say you're having the odd number, then all these are 0 when you get a coin equals to a head. Okay, so all the blue color number here are the value of X. So that means your X can be equals to 0, 2, 4, 6, 8, 10, 12. So this is by using the possibility space diagram. If let's say you don't like the possibility space diagram, then you can consider the tree diagram. But to me, I think tree diagram is a bit big. Alright. So when you are drawing the tree diagram, you can show that you're having head and tail, which is half and half. So maybe I should put it in this way. Tail first, okay, then head. So now they say that for tail, X is twice the score. So for the tail part, you have to show all the 6 score here. 1, 2, 3, 4, 5, 6. Okay, so you're having 2, 4, 6, 8, 10, 12. Yeah, right. So 2, 4, 6, 8, 10, 12. Then you have to list out all the probability here. 1 over 6, 1 over 6, 1 over 6. So you can see that all the score here, all this score here, I have multiplied them with 2 lah. All the score in the dice because they already said twice the score, right? Okay. Then after that, if you get a tail, then you have 0 for odd number and also the score on the dice if it is even. So that means I assume that I have odd number, so 0. So I have how many odd number here? 3, right? 1, 3, 5. So 1, 3, 5, 3 number out of 6, it should be half. Then after that, you should have 2, 4, and also 6. Then you list out the value as well, 1 over 6, 1 over 6, and 1 over 6. So this is by using the tree diagram, and this is by using the possibility space diagram. So it depends on which method you prefer more, right? Okay, then to draw the probability distribution table, you need to gather all the probability for the X first. Okay, so for tree diagram, if you want to get X equals to 0, very easy. So you take half times half, then you get a 0. But if you are using the possibility space diagram, the probability for X equals to 0, basically you need to take how to get a 0 here. It is head multiplied with the probability of 1, right? So it should be 1 over 2 multiplied with 1 over 6. And you realize that every single value here will be 1 over 2 multiplied with 1 over 6. So it can direct times multiply with 3 because of you're having 3 0 here. And all the probability are the same, which is 1 over 2 multiplied with 1 over 6. So for X equals to 0, you will have 1 over 4. Okay, then after that, my next score is X equals to 2. So to X equals to 2, I'm having 2 values of 2 in the table, right? This is 1 over 2 multiplied 1 over 6. Same thing happens for this one. So you can directly multiply with a 2. So by right, you should have 1 over 6. But if you are using the tree diagram, then you have to see where is your 2 coming from. So it should be 1 over 2 times 1 over 6 plus another 1 over 2 times 1 over 6. Okay, so if you are using tree diagram, then basically this is your calculation, right? So by using the table, this is how we calculate it. Right, then after that, we continue further, X equals to 4. So X equals to 4 means you are taking 1 over 12. 1 over 2 multiplied with 1 over 6, you get 1 over 12, right? And then you calculate how many 4 are there. So you're having 2 4 here, so times 2. So you're having also 1 over 6. Then you have X equals to 6. Only appear one time if you're in your table. It should be multiplied with 1. So you're having 1 over 12 here. Then 8. So you see how many times the 8 appear? Also 1 time. So it should be 1 over 12 as well. And after that, 10. Also appear 1 time, right? Okay, then after that 12. So 1 over 12 also appear one time, so it is 1. I think I saw a mistake just now, right? Where my 4 got 2 times, so it is times 2, correct? So x equals to 6. Sorry, I'm having 2 6 here. So by right, how the x equals to 6 should be also multiplied with 2. So by right, you should have 1 over 6 for this one. Okay, so now you have listed out all the value for the x and also the probability. To double check your answer, please add all the probability here together and see whether is it equals to 1. If it is equals to 1, that means very likely your answer will be correct. If it is not equals to 1, that means definitely your answer is not correct. Okay, alright, so after you are confirm your final answer here, then you can group them in the table form, which is easier for you to visualize later. Or maybe I put it at the bottom part. Wait there. Maybe I put it here. Okay, so for the first row of the table, I want to put in the value for x equals to x. Then the second column, I'm putting the probability. So like what we show here, right? We are having a few number here, 0, then 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. Then after that, I put in all the probability. So 1 over 4, 1 over 6, 1 over 6, 1 over 6, 1 over 12, and so on. Okay, so basically this is how we calculate the probability for every single value for x, and eventually we should try to compile them into a table form, right? Okay, so this is what we have for part A. Let's continue to part B. For part B, they are asking for variance of x. Okay, so now to find out the variance, you need to find out, there's a general formula. So the general formula for variance, right, is basically the expected value of x squared minus the square of the expected value. And to recall back how to get this one, basically it is a summation of x squared multiplied with the probability. Then for this one, basically it is the summation of x multiplied with p. Okay, so for me, usually I will start from the first step first. I try to find the expected value of x first. So how to find out the expected value of x? So you can see here, x multiplied with p. So you take the first x multiply with the first probability. So you're having 0 multiplied with 1 over 4. Okay, then plus 2 multiplied with 1 over 6. Then 4 multiplied with 1 over 6. And so on until the last value, which is 12 multiplied with 1 over 12. Okay, so if you try to simplify this part of answer, right, so you should be having 9 over 2. Yeah, then of course the next one, I want to find out the expected value of x squared. So if you have a look for the general formula, it should be x squared multiplied with the p. So that means I'm taking the x, which is the 0, I square it first, then only I multiply with the p. Same thing happen for the rest of the value. 2 is the x, right? You have to square it first, then only you multiply with the p, and so on. So try to simplify this particular value, you should have a 35. Okay, so after I successfully get expected value for x and also the x squared, then only I can find out the variance x. So variance x formula is 35. Expected value for x squared minus the square of the mean, which is 9 over 2 square. So if you simplify this particular answer, it should be 59 over 4. Or if you want, you can put it into the decimal number, 14.75. This is not a long decimal number, right? So you can keep your answer in this way, no problem. But if you want it to be safe, then you can correct it to 3 significant figure if you want. So for me, usually I prefer to keep it in a fraction form. To me, that is the how to say the safest way to put it in the fraction form, right? Yeah, so this is how we solve this question number 3. Okay, so we are now at question number 4. The heights in meter for white pine trees are normally distributed. So highlight the keyword normally distributed with the mean and also the standard deviation. So in a certain forest, there are 450 white pine trees. How many of these trees would you expect to have height? So height less than 18.2 meter. Okay, so in this question, we are talking about the height of the tree and they are normally distributed. So maybe we can let the x equals to the height of the tree. So if let's say x is the height of the tree, therefore x is normally distributed with the mean 19.8 and also the standard deviation 2.4. So when you want to write the parameter in this symbol here, it should be a variance. So it should be 2.4 squared. Okay, then they're asking you how many of these trees would you expect to have height less than 18.2. So before we can calculate the number of trees, we need to calculate the probability for the height. Height is x, right? So less than 18.2 first. So after I found the probability, only I multiply the total white pine trees, which is 450, then only I can get the number of trees that's less than this particular height. Okay, right, so since x is normally distributed, therefore to calculate the probability, you have to standardize it become z. So you'll be having z, then smaller than. So you take the value of x. How we standardize it, you have to minus the mean, minus 19.8 divided by standard deviation. Okay, then equals to the probability of z smaller than negative 0.667. So this particular probability or the area is equals to z greater than positive 0.667. So to find out the probability, I have to take 1 minus the positive value of z, which is 0.667. So you go to the normal distribution table, looking for 0.667. So 0.66 is this one, and 7 is 23. So by right, you should try to add the 7454 with 23 at the last 2 digits. So you should get 7477. Alright, so you go back to the calculation. You have to take 1 minus 0.7477. Okay, then from here you get 0.2523. Alright, and then a small suggestion here or small reminder here. Okay, so this particular step of standardization must be right up, standardizing the x become the z, right? So you have to show the step where you minus the mean divided by standard deviation. Okay, and then a small reminder about the value of z as well. So please make sure that you keep it up to 3 decimal places before you want to find out the value from the table. Right, so this one should be 3 decimal places. Alright, and this particular part must be shown in your solution. Alright, usually you will be given a mark, right? 1 mark. After you get a probability, this is not my final answer yet because they're asking for how many trees that is less than 18.2 meter. So to calculate the number of trees, you have to take the probability, multiply with the total number of trees. Okay, so by right, you should have a value with decimal number, so 113.535. Then, of course, when you are talking about the number of trees, right, we should try to round up or round down, become the whole number. So for this question, right, you can put it as 114 if you want. Number of trees equals to 114, or you can put it as 113. In marking scheme, usually they will accept both answers, either round up or round down answer as integer. Okay, so this is how we get the part A answer for question number 4. So let's continue to part B. Okay, so for part B, they are still talking about the heights, but it is now the red pine trees are normally distributed, still normally distributed. You know the mean, but we don't know the standard deviation. Okay, so maybe for this one, I will put the variable as the y, which is still the height of the pine tree, but it is the red pine tree. So it is still normally distributed. Mean is the 23.4. And then the standard deviation we don't know, so you just put it as sigma squared because the second parameter here must be a variance. So they give us some information here so that I believe they want us to find out the sigma, right? So it is known that 26% of the red pine trees have height greater than 25.5. So find the value of sigma. Okay, so same thing happened here. They already give you one information. So y greater than 25.5, the probability is equals to 0.26. So we go through the same process. Y is normally distributed, therefore you have to change it become Z first. So you're having 25.5. So minus the mean divided by standard deviation that you don't know, and it is equals to 0.26. If I try to illustrate this particular equation by using a diagram, right, a normal distribution graph, so the center is a 0. So to have Z greater than this particular value, it is equals to 0.26, which means that your graph should look something like this. This area is 0.26. And if we successfully find out this particular value of Z, then we can compare it with what we have in this part. Okay. Oh, all right. So now I realize there's a error here. Sorry, a careless mistake. It should be 23.4, right? It shouldn't be 23.5. Okay. So now I come back to my diagram here. I want to find out this particular object. So I have to find out the table in the reverse way from normal distribution table. Okay. So just now is you are given the value of Z, then you want to find out this probability. So now it's opposite. That means you are given the probability. You want to find the value of the Z. So I have to apply it, find out the table in the reverse way. But if you want to find the table in the reverse way, right, in the probability part, they didn't give you a small probability. So 0.26 is a small one. Less than less than half, we will say that it is a small area. So instead of using 0.26, I will need to use the 1 minus 0.26. I want to use the complement area here. So if you take 1 minus 0.26, you have 0.74. So I'm not going to use 0.26 because it is not provided in the formula booklet or in the table. So I will look for 0.74. And this 0.74 is the area, yeah? It is the area. So when I want to find the value of Z, area means all the value in the center. Z means all the area by the side. So my area is 0.74. So I'm looking the value from here. So where's 0.74? So find out one value that is smaller than 0.74 but closer to it. So I think I will take this one, 7389. So to make it become 0.74, you need to add 11 at the last two digits, right? Okay, so you have a look at the back. Is there any 11 at the back or not? So there's no 11, but the closest number is a 10. So you just take a 10. So read out the value for the Z, where it should be 0.643. Okay, so go back to the table. I know that this value of Z is 0.643. And it should be a positive value because from the diagram, right, the Z is on the right hand side of 0 after the 0. So it should be a positive. If the Z is here, then it should be a negative value. Right. Okay, so this is positive value here. So I will try to compare my value of Z, 25.5 minus 23.4 divided by sigma. So this value is actually equals to 0.643. So by using the help of calculator, so you will get the answer in a long decimal number, but of course you have to correct it to 3 significant figure. By right, your answer should be 3.27. So this is how we solve question number 4. Question number 5. In a class of 21 students, there are 10 violinists, 6 guitarists, and also 5 pianists. Okay, so there's a group of 7 to be chosen. Highlight the keyword chosen. That means your calculation later, right, actually involve the combination. Okay, the keyword is chosen. So your combination method will be usually having NCR, right? Without the permutation, I mean the sequence is not important one. So your calculation later usually based on NCR. So from these 21 students, the group consists of 4 violinists, 2 guitarists, and also 1 pianist. So how many ways can the group of 7 to be chosen? So they already tell you very clearly that you're having 4 violinists, 2 guitarists, and also 1 pianist in the group. So you just select them, right? So for the 4 violinists, you have to select it from the 10. So 10C4. Okay, then to make it complete, you have to multiply. Then how about the guitarist? So guitarist means you're having 2 and you would need to choose from the 6, so 6C2. And after that, for the pianist, 5 pianists, you want to choose one of them to be in the group, so 5C1. Okay, and it should be multiplied because your complete group, your whole group should consist of the 3 types of how to say, these 3 types of students. So I'm having violinist, guitarist, and also pianist. So you should multiply them to make it complete. So when you want to calculate the number of combination, it should be 15750. Okay, so this is a straightforward question. So let's have a look for part B. Right, so for part B, now they say that if there's another occasion in the group of 5 will be chosen from the 21 students. Okay, so the group must contain at least 2 violinists, at least 1 guitarist, and also at most 1 pianist. So how many ways can the group of 5 to be chosen? Okay, so I just tell you again, yeah, we are having originally 10 violinists, right? And then we are having 6 guitarists and also 5 pianists. This is what we have originally for the 21 students. And now I want to form a group of 5. So to form a group of 5, they actually give us some restriction here. So what I want to do is that I try to list out case by case. Okay, so let's talk about the violinist, guitarist, and also pianist. So they already tell us that your violinist should be at least 2. Guitarist should be at least 1. Then pianist should be at most 1. So it should be smaller or equals to 1. Okay, so you have to list out what are the possible case where we are having 5 members and it also fulfill all these conditions. Okay, right. So maybe for me, what I want to do is like I can start from 0 pianists first because they say at most 1 pianist only. So I start from 0 pianists first. If I'm having 0 pianists, I will have either 3 violinists or 2 guitarists. This is the first case. If let's say I'm having 0 pianists, I might also have 4 violinists and also 1 guitarist. So can I have 0 pianists with 0 and 5? This one not fulfill the condition, right? Because you must have at least 1 guitarist. Therefore, there's no more possible cases when you are having 0 pianists. Okay, so these are the possible cases for 0 pianists. And after that, I increase the number of pianists by 1. Oh, I recall something. I still have another possible cases here. If I have 0 pianists, I can have 3 guitarists and also 2 violinists. Because I have 10 violinists in total, right? 6 guitarists in total. So it is possible for us to have 2V, 3G, and 0P. Okay, so after I list out all the possible cases for 0P, then I start with 1. If let's say I want to have 1 pianist, then I can have 2 violinists and also 2 guitarists. This is one of the cases, 2 to 1. And if we fulfill all the conditions we have, if I have 1 pianist, I can also have this one must be at least 2 so it cannot be, the violinist cannot be 1, right? So you start from 2, then I increase the number become 3, so this one is a 1. If I have 1 pianist, I can make it as a 4, then I cannot make this at 0, right? So that means 401 is not a possible case or possible result that we want. Okay, then after that, I cannot increase the number of pianists anymore because the question did mention that I want to have only at most 1 pianist. So this is all the possible cases for us to select and form the group. So we need to select case by case. Okay, so for the first case, 3 violinists means 10C3, then 6C2, and 5C0. Okay, so you try and see whether you're able to get 1,800 or not. Then for the second case here, you are having 10C4, multiply with 6C1, multiply with 5C0. So by right, you should have 1260. Then how about the third case? So the third case is 10C2, multiply with 6C3, multiply with 5C0. So by right, if you didn't do any careless mistake, this value should be 900. Then please complete the rest of the cases. So 10C2 for this one, 6C2, and also 5C1. So for this, it should be 3375 if not mistaken. Then the last case is I want to have 10C3, then 6C1, and also 5C1. So if you press calculator, by right you should have 3600. Then what is the total number of combinations? So very easy. Total number, you just add all of them together. So by right you should have 10935. Okay, so for this question, before you start to find out the answer, you need to make sure that you have successfully list out all the possible cases. Okay, so you can maybe start from a certain criteria or certain sequence. Like for me, I start with the case where P is equals to 0 first. I list out all the possible cases, then followed by P equals to 1. Okay, yeah, so this is how we solve question number 5. Okay, so we are now at question number 6. There's a team of 15 runners took part in charity run last Saturday. So the time taken, they are taking the time. The time taken in minutes to complete the course by the runner from the falcons and also runner from the kites are shown in the table. So there are two groups of the runner here. Alright, so these are the time taken by them to complete the run. Okay, then draw a back-to-back stem and leaf diagram to represent this information with the falcons on the left-hand side. Okay, so you have to draw a back-to-back stem plot. Then the smallest stem should be a 3, started from 3. The largest stem should be started from 7. Okay, so we'll form the stem first. So we're having the stem in the middle, in the center. Okay, so where this is the stem. And then how can I put in the value for the stem? So like what I told you just now, the smallest value should be a 3. Then the highest value should be a 7. So our first digit will be the stem. Then the second digit will be the leaf. Okay, so you start from 3 first. I'm having 3, 4, 5, 6, 7. And please read the question very carefully. They say the falcons data should be on the left hand side. So this is falcons. And after that, we are having the kites. Okay, so for this question, very easy because you just need to put in all the value for the time taken provided in the table. So the first number is 38, so you just put 38 for falcons, the 8 here. Then 39, you put a 9. 42, put it under the 4. Then 44, 46, 48. So 50, 51, 52, 56, 58, 59. So this is longer. Then after that, 64, 69, and 76. Then for the kites also, you plug in all the values. So 32, 40, and 40 you have to put in for twice. 45, 47, 48. So 52, 4, 8, 9, 9. Where repeated number, you have to put it twice, yeah? Then 0 is a 6 already. So 60 is here. 61, 63, 65. Okay, so when you want to form this back-to-back stem plot, it is not too hard because the data has been arranged from the smallest value to the largest value. Okay, then after that, before you proceed to the next part, please don't forget about the key. So for the key, you can just write any number that you like. So as an example, I put in this one. So what does it mean? You have to write out the keys very detailed. So for this set of value, it means that 64 minutes. Okay, it's taken for the runners or falcons. So for me, I write a simple one. And after that, for kites one is 60 minutes. So 60 minutes for kites. Okay, so please make sure that you do always remember about the key, yeah? And when you want to write the key, please state out clearly what does it mean for you to write out the value in the table or in the stem plot. Then after that, the most important thing is please don't forget about a unit in the context of the question. So like for this question, they're talking about the time taken in minutes, right? So don't forget about the minutes here when you want to write out the key. Okay, so this is what we have for part 1. So let's continue to part B. Okay, for part B, they want you to find median and also the interquartile range for falcons. Okay, so median and interquartile range. So let us have a look for the stem plot that we draw just now. If I want to get median, okay, so maybe I put part B here, yeah. If I want to find a median, it should be the center value, right? The value in the center. I'm having 15 runners here, 15 time or 15 runners. The center one should be the 8th number because in front got 7, at the back got another 7. Okay, so the center one will be the 8th, the 8th number lah, okay, from the beginning. So you count where's the 8th number from the beginning. So 38 is the first one, 1, 2, then 3. The third one must be a 2. You cannot start from the 8 because you have to arrange it from smaller to largest value. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th number. Okay, so this is the 8th number. And if you try to read the value, it should be 51. So which means that your median should be 51. So we can write median is 51 minutes. Okay, then after that, they want you to find the interquartile range. So before you can find the interquartile range, right, you need to find Q1 and also Q3 first. So Q1 means lower quartile, Q3 means upper quartile. Okay, so just now when you try to find the median, right? So I know that the 8th number is the median. So in the first set of the data, the first half part of the data, you're having 7 number. The second half part of the data, you're also having 7 number. So that 7 plus 7 plus 1 in the center, it is 8. It is 15 number in total, right? Okay, so now to find the Q1 or lower quartile, it is basically the median of these 7 numbers. The median of these 7 number. So what is the median for these 7 number? The center value will be the 4th. Okay, so the median here should be the 4th. So again, you start from the first number here, try to count for the 4th number. 1, 2, 3, and 4. So by right, your 4 here, this particular value is 44. If you read 44, so your Q1 should be equals to 44 minutes. Okay, then after that, if you want to get the upper quartile, then you should look at the second half of the data, and it is a center value or it is the median of the second half of the data. So the second half of the data, you have 7 numbers. So the center one should be also the 4th number. So you have to calculate the 4th number after the median. Okay, so your median is 1. So I want to calculate 4th number 1, 2, 3, and 4. So the 4th number basically is this one. So if you read the value, it should be 59. So your Q3 should be 59. And next, they are asking for interquartile range. So to get the interquartile range, basically you have to take Q3 minus Q1. So what do we have here for Q3 minus Q1? 59 minus 44. And by right, if you didn't do any careless mistake, it should be 15 minutes. Okay, so this is what we have for part B. Alright, then let's continue to part C. Okay, so for part C, they are given us all the details here about the summary, the summation of the value. So we are having X and Y. X means the runner from falcons, Y means the runner from the kites. Then it is given that all the summation here, summation X square, summation Y square. Find the mean and standard deviation taken by all the 30 runners. So you're having all the 30 runners here from the 2 teams. Okay, so to find out the mean and also the standard deviation, since we are having 2 groups, right? So to calculate the mean, now you have to consider the summation of X from the both group. So I'm having summation of X and also the summation of Y. Then I have to divide it by the total N. So the total N for this case is 30. Okay, then how can we find out the standard deviation? So to find the standard deviation, the general formula is, if let's say I'm having only one set of data, is summation of X squared divided by N. So for this one, I have to consider both summation of X squared plus summation of Y squared divided by N. So N is 30. Then minus, you have to minus the mean square, right? So the mean that you calculate just now, you can substitute it here and then you square it. Okay? So this is what we should do for this part. So let's have a look and we try to put in all the values. Okay, so let's start with the mean. So what's the mean here? So by right, your mean is 792 plus summation of y, which is 783, divided by 30. Okay, so the mean that you get, if you didn't do any careless mistake, by right, it should be 52.5. Alright, then how about the standard deviation? So to calculate the standard deviation, follow the formula that I showed on top here. So it should be summation x squared, where it should be 43504 plus summation y squared 42223 divided by 30. And just now you get your mean, right? So minus the mean is minus 52.5 square. Mean square, so it should be 52.5 square. So if you try to use calculator and help you a bit, by right you should have a long decimal number, and we will cut it short into 3 significant figures, which is 10.1. Alright, yeah, so this is basically how we solve the question number 6. Okay, so we are now at question number 7. In a game, players attempt to score a goal by kicking a ball into the net. So the probability that Lino score a goal is 0.4 on any attempt, independent of all the other attempts. So the random variable x means the number of attempts it takes to score a goal. So that means for this question, if you have a look for the structure of the question, that means you attempt until you get a goal, right? It is actually the number of attempts. So when you try out something until you get the result that you want, so we call this as a variable under the geometric distribution. Okay, so from here by right you should know that this is basically x is geometric distributed with the p, which is 0.4. Okay, then they want you to calculate the probability for x equals to 5. So what's the general formula for this one? Okay, so for a geometric distribution, to find out the probability of x equals to r, it should be equals to the q power r minus 1, then multiply with the p. That means that you are having the failure for the r minus 1 time. Then the last time, we are getting the success trial. Okay, so by right, this is a general formula. So when x equals to 5, so that means you should have 0.6, which is the 1 minus 0.4, you get 0.6 as the q. So r minus 1 means a 4, and then multiply with the p. So the p is 0.4. So from here, by right, you will get the answer 0.05184. You can keep this as the answer. If not, then you can try to change it become 3 significant figure. So this first question, I think is very, very straightforward. Alright, then let's have a look for part number B. Okay, so for part number B, they're asking for x equals to 3, greater than equals to 3, but smaller equals to 7. Alright, so if you have a look for the so I simply draw, yeah, okay? So I'm having 2, 3, 4, 5, 6, and 7. So they say I want to calculate the probability between 3 until 7. So 3 until 7 means that this one. Okay, so this area here. Okay, so to find all this probability, you can either list out the value of x one by one, then apply the calculation. Or what you can do is like you can use a shortcut formula. So the shortcut formula basically is this one. Where should I write? Wait, maybe I write it here. Okay, so I'm having a shortcut formula where x smaller equals to r. Must have the equal sign one, yeah? X smaller equals to r, it will be equals to 1 minus q power r. So this is a shortcut formula you can consider to use that if you feel that it is helpful. Okay, but this formula, I think it's not provided in the formula booklet. Alright, okay, so I come back to the question here because I want to find the probability between the 3 until 7. So I can actually write it become x smaller equals to 7. If let's say x smaller equals to 7 means that it includes the whole part here. And you need to minus this part. Okay, so when you need to minus this part, that means that you have to minus x smaller equals to 2. So you have to minus the 2. You shouldn't include the 3 because 3 is included in the answer that they want. Okay, so 3 cannot be removed from the whole part of the 7. So you are taking x smaller equals to 7 minus x smaller equals to 2. Then after that, only apply this particular formula. Okay, so this is what I plan to do. Right, so I'm having the probability of x smaller equals to 7 minus the probability of x smaller equals to 2. So x smaller equals to 7 is 1 minus q. Q is 0 0.6 power r. R is a 7. Then minus again 1 minus q power 2. Okay, because in this case the r is equal to 2 now. Okay, then you try to simplify your answer. By right, you'll get a long value like 0 0.3320064. And please correct it to 3 significant figure, which is 0 0.332. Okay, so this is how we use the shortcut formula here to calculate the probability. If let's say you don't want, then you have to list out the value one by one, where you need to find out the probability for x equals to 3, probability for x equals to 4, x equals to 5, x equals to 6, and also x equals to 7. So you need to list out all this formula here for 3, 4, 5, 6, 7. Then total them up, you will also get the same answer. So to me, I think this one is more, is slightly shorter, right? Okay, instead of listing out all the probability calculation here, which is longer. Okay, so this is what you have for 7b, and let's continue to 7c. Okay, so for 7c, they want us to find the probability that he scored the second goal on or before the 5th attempt. Okay, so if let's say they say the second goal on or before the 5th attempt, means that it shouldn't include the, should it include the 5th? On or before, so it is actually included the 5th one. Okay, so maybe you need to do it slowly. So maybe now I try to start from the smallest value first. So they said seconds go on or before the 5th attempt. So the very first possibility is I can have my second goal on second attempt. Okay, so maybe some of you might want to ask why the second goal cannot on the first attempt. Impossible, ma. If you are having only one attempt, how can you get the second goal, right? How can you get 2 goals? So it is impossible. So the first possible outcome is you get the second goal on second attempt. That means what? That means the first goal in the first attempt. So first goal in the first attempt is 0 0.4. Then second goal on the second attempt is also 0 0.4. Right? So you're having 0 0.16. And after that, you might have second goal on third attempt. So how can I find the second goal on third attempt? So you try to imagine here. So first attempt, maybe you can draw the outcome. So you might have first attempt you get goal, you got the goal. Second attempt you didn't got the goal. Then the third attempt you get the goal. So this is a case where your second goal is on the third attempt. It is possible also that the first goal, the first attempt you don't go it, you didn't get a goal. Second attempt you get a goal, and the third attempt you also get a goal. So these two cases, right, are basically the result for second goal on third attempt. Yeah. All right. So any problems so far? Okay. So if let's say you're having the second goal on the third attempt, there are a few ways for you to do it. Of course, you can find the probability one by one. So this is 0 0.6 or 0 0.4, 0 0.6, then 0 0.4. Okay, then this one is 0 0.6 times 0 0.4 times 0 0.4. Then you add the probability together. Right, so for me, because I can foresee that later, right, I'm having quite a long result, yeah. So I will try to use a shortcut here, where I will treat these first two attempt as a binomial distribution. So that means I'm having 2 attempts in total, and I want to find the probability that one of them actually score the goal. So I'm using binomial distribution for these 2. Then the last one, right? So the last one here basically is directly multiply the success rate, which is the 0 0.4. So I'm trying to do this. So we are having two cases here, right? So by right, it should be a binomial distribution with 2, and also the success probability is 0.4. So you can see that for the 2 attempt here, I only score 1 in either of these cases. All right, so what is my calculation is, I will write out 2C1, 0.4 power 1, 0.6 power 1. That means 1 success and 1 failure. Then the last one is always 0.4. That is a third attempt. And the third attempt is a go. The second go and third attempt, right? Yeah, so by using calculator to help you, you should get the answer 0.192 for this case. Okay, so the remaining of the calculation, I will still using the same concept here. Okay, so let's have a look for the next case. You should have second go on the fourth attempt. So I don't want to list out all the possible cases anymore. It can be quite long. So I will just take one example. So second go on third attempt, on fourth attempt means that you're having 1, 2, 3, 4 here. The fourth one is score a go one, the fourth attempt, and this is the second go. So that means for the first 3 attempts here, you have 1 go only, 1 go and then 2 cross, right? So I will treat this as binomial distribution. Total number of try is 3 and the success is 0.4. So I want to get 1 go. So when I want to calculate the probability, it should be 3C1, 0.4 power 1, 0.6 power 2. Then the last attempt still a success rate, which is 0.4. Okay, then for this one, I will get 0.1728. Then next one, second go on the 5th attempt, because they say it's on or before, right? So you can write out the last case here. The second go is on 5th attempt. So same thing happened here. I will have 5 attempts here. The last one is a go one. And then for the first 4 attempts here, you have only 1 tick and also 3 cross. So I will treat as binomial distribution. 4 attempts in total, and I'm interested for the number of success. Okay, so the number of success is a 1. Therefore, I'm having 4C1, 0.4 power 1, 0.6 power 3. Then the last probability, the last attempt is always a go, so 0.4. From here, you get 0.13824. Okay, so after I calculate all the possible cases here, although it is a bit long, but I hope that when I write out in this way, it is easier for you to understand how I get all this calculation here. Okay, so of course, if you want to get a final answer, you have to calculate the total probability. Please add all the probability on top together, and by right, you will have 66304, I think. Right, and after that, you should correct it to 3 significant figure, where it should be 0.663. All right, yeah, so this is how we get the answer for part C. And let's continue to part D, which is the last question. Okay, so now here they said Lino has 75 attempts to score a goal. So he tried out 75 times. Okay, so use a suitable approximation, highlight the keyword approximation, to find the probability that he scored more than 28 goals, but fewer than 35. Okay, so the keyword is approximation, which means that by right, your original distribution should be the binomial. You're having 75 attempts in total, then the success rate to get the goal is 0.4. And approximation means that you have to change it become normal. Okay, but of course, when the question asks you to change it become normal, it means that it already fulfilled all the condition. So just to recall again, what is the condition for changing binomial to normal? You should have bigger n, which is n greater than 30. And then you should have the second condition where NP should be greater than 5. And also the third one should be NQ greater than 5. Okay, so this is the condition for you to change it become the normal distribution. So to get the mean in normal distribution from binomial, you are taking n multiply with the p. So n multiply with the p. When you take n multiply with the p, so by right you will get 30. Then after that, for variance part, you are taking n times p times q. So n times p times 0.6, which is a q. So by right, you should have 18. Okay, so after you change binomial become normal distribution, so find out the probability lah. More than 28 goes. So that means more than 28 shouldn't include the 28. Fewer than 35. So not include 35, but fewer than it. Okay, so this is a binomial distribution. So to change it become normal distribution, you have to standardize, you have to apply continuity correction. It is because of this is discrete random variable. This is continuous random variable. Okay, so from discrete to continuous, you have to do some adjustment on the value of x. Okay, all right. So what is the correct continuity correction? So you can actually draw a few number line here. So you're having 27 maybe, then 28, 29. Then maybe this is 33, 34, 35, and 36 essay. Okay, when they say x is between 28 to 35, that means it doesn't include the 28, does not include the 35. So this is a probability that you want to find out. So basically, you want to find out 29 until 34. Excuse me. All right. So to get a continuity correction, you have to make sure that the value that you use cover the area that you want. So from the number line here, you can see that it is between 28 to 29. So the continuity correction should be 28.5. Then from the diagram also, you can see that the dotted line should be between 34 to 35. So the continuity correction should be 34.5. Okay, so this is the continuity correction. So please don't forget about it when you are trying to do the approximation from discrete to continuous random variable. Okay, so since I already know that this is normal distributed, right? So you have to change x become the z by standardizing them. So how to standardize the variable? So you have to minus the mean divided by standard deviation. Same thing happen for the value 34.5. You have to minus the mean divided by standard deviation as well. So you use the calculator to help you a little bit. So for this one, if you don't do any careless mistake in the calculation, you should have negative 0.354 to 1.6061. So you can see that I try to keep my value of z in 3 decimal places. Okay, then now I want to calculate the probability. So if I draw the diagram, what am I interested is I want to find out the area. This is 0. I want to find the area between negative 0.354 until 1.061. So this is a probability that I want to find. Okay, and if I want to write the steps properly, maybe I want to take this particular area, the red color area here. When I want to write out this red color area, I will write out as z smaller than 1.061, right? Then minus, I need to minus this green color area. Because if I minus this green color area from the red color one, then I will take the shaded area that I get, what the question wants. Okay, so I have to minus z smaller than negative 0.354. Okay, so 1.061. 1.061, go to the table. Looking for 1.061. 1.0 is where? 1.0 is here. 1.06 is this one. And then 1. So you take 8554 plus 2. So should be 8556. Okay. So for this particular probability, it should be 0.8556. Then minus, for this green color area here, you have to take 1 minus z smaller than 0.354. Okay, so I go for table, looking for 0.35, 6368, and then 4 is 15. So that means you have to take 6368 plus 15. So by right, you should be having 6383. Okay, so you go back to the table again, then you have to take 1 minus 0.6383. Alright, then after that, we try to simplify the value, 0.4939. then of course, usually to be on the safe side, I still prefer to change it into 3 significant figure, where it should be 0.494. Okay, yeah, so basically this is how we solve this question number 70. And this is the last question for this paper. So thank you very much for watching the video.